Plotting quartiles. Suppose that we're evaluating the performance of a large number of mutual funds. An effective way to capture the central tendency of the group, along with the distribution of individual observations, is through a box and whisker plot, which is what this is right there. So let's have a closer look. And let's start from the very top. So this observation represents the highest value in the data set. So what we have here is a number of mutual funds, and each one has their return. So this here represents the return of the mutual fund that had the best performance, and naturally this here represents the return of the mutual fund that had the worst performance. But that's not enough information, so we like to look deeper because we're looking at the whole data set. So from the highest value to the top of the box here, we have the top 25% of all the mutual funds in the data set. So 25% of the highest returns fall within that range. And then naturally, of course, 25% of the lowest performers fall within this range right there. So then the conclusion is that 50% of the data set is somewhere in between there. Now, the first misconception is that, shouldn't this segment here be the same as that segment there? Absolutely not. Because all we're measuring is the top 25 performers. What if these top 25 performers had return figures that were very close to each other, whereas the bottom 25% of the performance had a wider dispersion of returns? So just for an example, just for illustration, let's just say this individual earned 30%, so that's the highest performer, and then the 75th percentile earned something like 28%. But at the lower end, maybe the 25th percentile earned something like 10%, and the slowest return was, let's say, minus 5%. So you could see that in both cases, this represents the top 25, and this represents the bottom 25. But if you look at the top 25, the only thing separating the performance between the top performer and the 25th percentile is 2. Whereas if you look at the bottom quartile and you look at the range of performance they had, the gap is 15%. So this is why the top segment right here is different in length than the bottom segment. And once again, this just means the distribution of the top 25 performers were tighter. They had closer return figures. And at the bottom 25, distribution was wider, meaning there was a greater range in possible returns. And as we said, in between the 75th percentile here and the 25th percentile, in between you have 50% of the observations, and that's referred to as the interquartile range. And you can see why it's called that, because this range here is in between the top quarter and the bottom quarter. Now, the next thing that the data tells us is what was the mean and the median in the distribution. And again, a reminder that the data set includes a whole bunch of observations from the highest value to the lowest value. So we can have, say 500 different mutual fund returns between here and there. So then naturally, when we have such a large data set, we like to know the mean and the median. So the mean, of course, is the arithmetic average. So it looks at the values of all the observations, whereas the median just looks at the value of the middle rank observation. So here's a more elaboration on what we just discussed. So the easiest way to interpret the plot is by starting at the top. That top is the highest return end in the group, continuing down the line until reaching the box yields us the segment representing the top 25% of the performers. That would be the top quartile, and then the box itself is the interquartile range, and as we said, that just represents the middle 50% of all returns. And finally, the bottom segment is 25% of the worst performers in the group, or the lowest performers in the group. And actually, what we want to do is, we want to hire managers, or we like to be managers that are ranked in the top quartile, naturally. And this is what this box and whisker is used for. So this here represents the performance of all the managers, and we simply like to see where our manager fits in. And then the last paragraph, while the quartiles reveal how the returns are distributed from highest to lowest, the plot also reveals central tendency by showing us the mean and the median. And in this case, we could see that the mean lied above the median. So we've seen this in a previous LOS module. So when the mean is above the median, remember what the difference is, right? The mean looks at the value of all observations. So if the mean is higher than the median, that means these outlier positive observations must have been very large. Now the median wouldn't care because the median just looks at the middle value. So if these numbers become very large, the only central tendency measure that's going to be dragged up would be the mean.